So good afternoon. My name is Joel Savat. I'm one of the genetic counselors with the GenomeConnect team. I'm joined today by Caitlin Cooney and Gabrielle Milliken, who are also on the GenomeConnect team. The purpose of today's webinar is to give an overview of GenomeConnect. We've had a number of folks who registered recently and get emails from individuals who are interested in potentially learning more to explore if they'd be interested in participating. So our real goal today is to give you more information about GenomeConnect, what we do, why we do what we do, and answer any questions that you have. Today's webinar, like all of our webinars, will be recorded and we posted on our YouTube playlist after the webinar for folks who might want to observe, view after the fact. And we do have another webinar scheduled for later this summer, fall on September 25th that will talk a little bit about variant classification, variants of uncertain significance, and reclassification. Caitlin Cooney, who's on the call today, will be giving that webinar. And if you registered for this webinar, you should have had the option to also register for that webinar. So we welcome you there. A few other housekeeping slides. We have already found the Q&A box, or some of you have, but we will have a little bit of time at the end of today's session to answer questions that you might have. For those of you who provided questions as part of registration, I've incorporated those into the slides that we'll be talking through today. But if you have questions as we're chatting through slides, feel free to drop it in the Q&A box, and we will try to get to some of those in the time that we have set aside. So with that, let's jump in. So as I said, we will talk about GenomeConnect as a whole, providing an overview and really honing in on why we engage individuals who've undergone genetic testing and data sharing. We'll highlight the potential benefits of participating in GenomeConnect for the genomics community as well as for individual participants. And then, as I said, we'll end with a question and answer, any questions that you all might have. So before we jump into GenomeConnect, I think it's helpful just to review a little bit about genetic variants. We're not going to review a ton of concepts here. Of course, come back in September if you're interested in more about variants, variant classification, and reclassification. But understanding a little bit about genetic variants is key to building on why GenomeConnect does what it does and how it might be beneficial. So let's start there. Each one of us has trillions and trillions of cells that make up our bodies. They're sort of like bricks that make up a house. We have different types of cells, our hair cells, skin cells, brain cells. And in each of those cells is our genetic material, or our DNA. Our DNA is kind of like our body's instruction manual, and each individual instruction is called a gene. Genes code for proteins, and those proteins have jobs in our body like helping us digest our lunch, helping our brain develop, helping to make up our heart. To keep our DNA organized in our cells, it's wrapped very, very tightly into chromosomes or structures called chromosomes. And this keeps our DNA organized as our cells are dividing, making copies of one another. As I said, wrapped up tightly at those chromosomes is our DNA, and our DNA provides instructions to make proteins. And as I said, they have different roles, responsibilities in the body. Our DNA is made up of letters called nucleotides. There are 4 different nucleotides that make up our DNA: A, T, G, and C. And our body reads these nucleotides to make protein. So these letters are read out and our body says, all right, this is going to make this protein building block. This is how we're going to put this protein together. We all have many changes in our DNA. These are called genetic variants. Some genetic variants affect how proteins work in the body, can cause developmental or health differences, and some are what make us who we are. They're just differences that we have that just make us unique. But any little change in our DNA, that's what we call a variant. There are different types of variants depending on the size, the scale, how much DNA is impacted. So we can have genes at the chromosome level or at the gene level. At the chromosome level, we might have an extra copy of a chromosome, like in the case of Down syndrome or trisomy 21. We might have a missing or extra piece of a large piece of the chromosome, what's called a copy number variant. Or we might have a single letter difference in a gene, what's called a sequence variant. Different types of genetic tests will detect different types of genetic variants. Many of you on this call may have undergone genetic testing, or a family member might have had genetic testing, so some of these might be familiar to you. But we have some tests that help us look at the chromosome level. So a karyotype, we're looking at chromosomes under the microscope, counting numbers of chromosomes, looking for very large missing or extra pieces. We could do a chromosomal microarray that detects small copy number variants, so smaller missing or extra pieces at the chromosome scale. And then we might do sequencing, where we actually read through the letters of someone's DNA sequence to look for changes, to look for variants. And there are different sequencing tests. We might look at a single gene. We might look at a set of genes that are tied to something like hereditary cancer, for instance, where we're looking at multiple genes at once through a gene panel. Or we might be casting an even wider net with something like exome sequencing that looks at all parts of the genes that code for proteins, or even genome sequencing that looks at all of our genetic material. Our ability to detect genetic changes through these types of genetic testing has really improved over the past few decades. It wasn't that long ago where all we could really do was a karyotype, but now we are able to sequence all of the letters in someone's DNA sequence through genome sequencing. While our ability to detect variants has really improved over the years, sometimes it can still be like looking for a needle in a haystack when we're trying to answer the question of what variant is tied to health problems, to disease, to developmental differences, to risks for future family members. Sometimes it's hard to understand what variants are part of what just make us who we are, and which ones are going to increase our risk or cause disease. Anytime a genetic testing laboratory identifies a genetic variant through testing, they work to try to answer that question, is this tied to health and disease? And there are a couple of steps in that process. Again, we are going to talk about these sort of briefly and broadly today, but that webinar in September will dig in a little bit more if you want to learn more about these things. So the first question that the lab will ask is this specific gene tied to disease? What do we know about this gene? We have tens of thousands of genes, and some of them we have a really good understanding of its role in health and development. For example, the BRCA1 or the BRCA1 gene, that's a gene that we have a really good understanding is tied to cancer risk, and when it's working well in the body, reducing risk for cancer, preventing cancer. But other genes we know very little about. Maybe we haven't studied them a lot. We don't know if it's tied to health or disease. So first, the lab asks, well, what do we know about this specific gene? If we don't know a lot about that gene, then that genetic change will always be classified as uncertain because we still have a lot to learn. But if we know that that gene has a relationship to health and disease overall, then we can ask more questions about that specific genetic change, that specific variant, and how it might be impacting how that gene works in the body. So if I have a change in a BRCA1 gene, then I know, yep, that's tied to disease, and I can ask more about that specific genetic change. When the lab's trying to evaluate that specific genetic change, they ultimately want to classify it on the spectrum from benign to pathogenic. Benign and likely benign, sorry for my going a little too fast. Benign and likely benign mean that there's not evidence that that specific genetic variant will impact how that gene works in the body, cause disease. Likely pathogenic and pathogenic, there is evidence that it will impact how that gene works in the body, that variant is impacting things, does cause disease or increases risk. And then we have that uncertain bucket in the middle where there's just not enough information to say one way or the other. To put a specific genetic change into those buckets, the lab will ask questions like, has this variant been seen in healthy individuals in the general population? Has the variant been seen in people with similar symptoms? Have similar variants been found in others who have symptoms? What other variants were found through testing? Was the variant passed through the family? Is it new and unique in that individual? What does the family history look like? How does the variant impact the protein specifically? Does it make the protein shorter? Does it change just one building block? And has anyone studied the effect of that specific variant in the laboratory? Ultimately, they use all those pieces of information to come to a classification on that spectrum from benign to pathogenic. Uncertain results, unfortunately, are common. We have much to learn in the realm of genetics and health, and genetics is a constantly evolving field. As I said, we have tens of thousands of genes, and we don't understand all of those genes. We have many that we're still learning their role in the body, their role in health and development. And so if a gene we don't quite understand, if there's a variant found in that, it's going to be an uncertain result. Between 16 and 37% of patients who undergo genetic testing receive uncertain results through their testing. So we know that these are common and that we have much to learn to better answer questions around, is this gene tied to disease? Is this variant pathogenic? Even if we have a variant that we classify as pathogenic, that we think it's tied to health and disease, we still often have a lot to learn about genetic conditions. So we might know, yes, this gene is tied to disease. Yes, this specific genetic change causes that condition. But we might still have questions around, well, when do symptoms typically begin? Are there certain genetic changes that cause certain symptoms? Like maybe individuals with this specific variant are more likely to have this risk compared to people with a variant over here in that same gene. We also have questions around how to best care for patients with that condition or with changes in that gene, and might still be learning about all of the symptoms that we see in individuals with that change or how often we're seeing those symptoms. So we can learn a lot more about genes, about variants, because some of them are uncertain. We don't totally understand them. Even for those that we have a good understanding are tied to health and disease, there are a number of additional questions that we still can answer around that specific condition, how to best care for individuals with that condition or with that genetic change. And that's really where the Clinical Genome Resource Project that GenomeConnect is a part of comes into play. So the ClinGen, or Clinical Genome Resource Project, is an NIH-funded project that's really focused on building an authoritative resource that defines the clinical relevance of genes and variants, that defines what genes are tied to disease, what variants are pathogenic, so that that information can be used in research and to better care for patients. Ultimately, the goal of ClinGen is to improve clinical care, inform clinical care, and ensure that patients are receiving best care they can. There are a number of pieces of the ClinGen project that you can see on this infographic. And the one that we'll focus in on is GenomeConnect, and we'll touch on a few others during the discussion today. So ClinGen has encouraged a number of groups to share data, because really the first step that ClinGen feels in better understanding genetics and health, what variants are tied to disease, is pooling as much information as we can together. So ClinGen has engaged clinicians, genetic testing labs, researchers, and even patients in collecting as much information as we can. ClinGen engages patients through GenomeConnect because they felt as though patients could serve as an important source of genetic and health information. I think I don't have to tell you all on this call, but patients and their families are often experts about their own health history, and they can provide much more detail about their symptoms over time, diagnoses. And ClinGen felt that access to this additional detailed information could be really helpful as we work to understand what genes are tied to disease, what variants are pathogenic. As a result, GenomeConnect was launched 10 years ago as a way to engage patients in data sharing. So then let's move into a little bit more about GenomeConnect. So GenomeConnect is the ClinGen's online patient registry. It's open to anyone who's had genetic testing, regardless of diagnosis or genetic test results. So it's not gene or disease specific. The platform, consent, and documents are all available in English and historically have been available in Spanish, and we're working on updating our Spanish translations right now. Participants enroll online and they're consenting to de-identified data sharing and recontact over time. They then share their genetic information by uploading their genetic test reports, and they provide health history via surveys And the whole process from consent, sharing genetic results, and that initial health survey takes about 15 to 20 minutes. GenomeConnect is very serious about protecting privacy of our participants. We understand that this genetic and health information can sometimes be sensitive. And so our registry is built on a HIPAA compliant platform, and the whole project is governed by an institutional review board here at Geisinger. And only individuals on the GenomeConnect team, really Caitlin, Gabrielle, myself, and a couple of others who aren't here, have access to the registry platform. It's not open or available to others broadly. So let's talk a little bit more about each of the individual steps that I just outlined on that slide. So first, individuals sign up and consent online. This is a screenshot from our website where an individual would go if they're interested in enrolling, or if they've already enrolled and want to log back into their account. As I said, there's a process to set up an account, and then an individual will review our consent form. The consent form essentially includes de-identified data sharing of genetic and health information with databases such as ClinVar. We'll talk a little bit more about that today. Recontact over time for additional data collection. So we might reach back out to participants in the future if we have more questions about their health history, or if it would be helpful to know more about all of the evaluations they've had. There are also some options in that consent form, including the ability to connect with other participants based on genetic test results, and the ability to receive updates about genetic test results that an individual might have received, things we also will talk more about today. The registry is designed so that families can register together. So it's designed to allow individuals to enroll themselves and also to enroll their dependents if they wish to share information on them as well. Examples of dependents include children under the age of 18 or an adult that an individual can make medical decisions for. If an individual wants to enroll a dependent, they first create an account for themselves so that we have their contact information, their information, and then they can add their children dependents later in the registration process. A common question we get is if I have to enroll my children, is this a required step? And really, participants only should add dependents if they're interested in enrolling them in GenomeConnect, have the ability to consent on the behalf of that individual, and are interested in sharing their data. So if I have 3 kids, but I'm really focused on sharing the genetic testing results that I've had, I only have to enroll myself. That's the only person that I will add to my online account. If I want to enroll 2 of my children because they've also had genetic testing, I have the ability to do that within my same account and make sure that all the family is sort of enrolled together, nested together. So after consenting, the next steps are to complete a health survey and upload a copy of the genetic test report. So in terms of the health survey, because GenomeConnect is not gene or disease specific, we start with a general health survey that's really trying to get a complete picture of health kind of across the body. So some individuals might say, well, I had cancer genetic testing and you're asking me about my heart health. This is really intended to get a complete picture on our participants. The survey asks general questions across various body systems like issues with heart, issues with brain, issues with lung, and then we'll assign more specific questions based on any systems or categories that the participant says they have had an issue with. So if someone says, I have a heart issue, we'll then ask them more about what type of heart issue and collect more detail from there. Additional surveys might be assigned based on the participant's initial responses to this survey. So if someone says, yes, I have a heart issue and it was a heart defect that I was born with, later on, we'll assign them an additional survey to capture more information about that heart defect, surgeries that they might have had, more information from there. A couple of notes. All of the surveys are assigned within participants' GenomeConnect accounts. So accessing those surveys, if you get a reminder for please complete a survey, the first step is to log back in and you'll see it right there on your profile on your dashboard. Sometimes we will assign a few surveys together, but it doesn't mean you have to complete them all in one sitting. By all means, you can log back in, take them later if you don't have time to complete them all at once. As I mentioned, we also ask participants to share a copy of their genetic test results. Participants share their genetic test results by uploading a copy of them from a PDF or an image file. If they no longer have a copy, they also can provide permission for GenomeConnect to request their records from the lab that performed their testing or the doctor, genetic counselor that ordered their testing. Our team, once we get that report, reviews the report and pulls out any information about the genetic change in a structured manner. So rather than asking participants to input the gene, the specific variant, we ask you to upload a report so that our team can pull all of that information out, ensure that we have all of the details that we need to describe that variant accurately. From there, once we collect genetic and health information from participants, we de-identify that information, so pull information about name, date of birth, other identifiers off, and submit it to a database called ClinVar. ClinVar is a publicly available database that holds de-identified information about variants and their classification, so their relationship to human health. It's a public and freely available resource that's used by doctors, genetic counselors, genetic testing laboratories, and researchers. And it's a database that's submission driven. So it relies on all of these people submitting data to the database so that it's available for others to use. ClinVar is really the database that we use to pool resources and knowledge in an effort to better understand genetics and health. To show you a little bit more about what ClinVar looks like and how we submit data, this is a screenshot from the ClinVar database. You can see up top that it provides general information about a genetic change. So up here we have general information that this is a BRCA2, so that's the gene variant. And then these letters and numbers here are how we name this specific variant. If you're interested in more about what the C dot and P dot mean, we have a number of videos on our YouTube playlist that break that down, walk through that a little bit more. But up here is just general information about the genetic variant. If you scroll down, you then can see all of the submissions from various laboratories, researchers, and clinicians. So in this case, there are 5 submissions from genetic testing laboratories, which really demonstrates how labs are submitting data to this resource. And then this last submission here is from GenomeConnect. A couple of things that I like to note about our submissions as GenomeConnect. We aren't independently classifying the variant, but we are sharing the information as it appears on our participant's genetic test report with additional details from our participant. So we can click in and see a few more details from there. You can see that this specific variant from our participant was classified as uncertain by the testing laboratory. We have the testing laboratory there, the day that it was classified, and then some health history information from the participant based on their health survey responses. The GenomeConnect submission differs a little bit from the laboratory submissions in that we're providing these additional details if we have them. Most labs submit many variants at one time, and because of that, their submissions are often very high level. They'll say, my classification is uncertain significance, and that's really it. But because we're interacting with participants, with patients who've had testing, we can provide a few more details, including that health history information. And if we know if the variant was passed through the family, we can also include that. Another common question that I get from participants or prospective participants is, well, how quickly will my variant make it into ClinVar? And I wish I could say that it was a quick push of the button. As soon as you enroll, it's in that database. But this does take time for our team to review genetic test reports, prepare all of the information to be submitted to ClinVar. So we do share variants in batches several times per year from participants who've enrolled. So it's not immediate, but we do work to get that information into the database. Another piece about GenomeConnect that I wanted to highlight is that we are just one of many patient registries. We acknowledge there are many other gene and condition-specific registries that are collecting valuable information. And some registries might not have the ability to submit data with ClinVar in their current registry, just as a part of how they're set up. But we have created a process of working with other registries, with other research studies who are engaging patients with genetic testing or genetic diagnoses to make this data sharing piece to ClinVar possible. So some folks might have learned about GenomeConnect from the PROMPT study. Others might come to us from other gene or condition specific registries. And we have a real goal of engaging as many patients in data sharing as possible and getting this information into ClinVar. To give you a sense of how many folks have participated to date, this is just a screenshot of our participation over the past 10 years, 10 plus years now. From those 10 years, we've been able to engage more than 13,000 individuals in data sharing from GenomeConnect or from registries that we work with. And we've been able to work with 10 external registries who weren't sharing data with ClinVar to help them do that same, get information into that database. So now let's talk a little bit more about why this data sharing is important, or why we feel like engaging individuals in this data sharing can be useful. First, we have noted from our submissions that engaging individuals who've had genetic testing themselves in data sharing with ClinVar is a way to get more variants into the database. So when we look at our submissions, about a third of the time, that genetic change that our participant has chosen to share isn't in the database, wasn't shared by a laboratory or by a clinician, by a researcher before. And so really a participant taking the time to enroll in GenomeConnect to share their information means that that variant is getting into that database, and that information about that variant can be used to better understand genetics and health. All of our submissions, we've noted, include additional details. So some of the variants are novel, aren't in ClinVar, are only in there because of our participant. But when we look across all of them, even if that variant has already been submitted, we're seeing that we're contributing additional information like health history details, like inheritance information, or if it's been passed through the family, just information that often isn't included in those lab submissions. So really, from our experience, individuals engaging in data sharing is useful because it makes more variants available in the database and more details about health history, information that can be really useful as we try to answer questions about genetics and health. To illustrate this, I want to share a case example from a GenomeConnect participant that describes a little bit about how really patients engaging in data sharing can be useful to our understanding. So for the purpose of this discussion today, I will call this participant Ella. That is not their name, but it's helpful to use a name as we talk through the story. So Ella is a pediatric patient, had a history of seizures beginning in infancy, and she had genetic testing ordered many years ago at this point, back in 2015, to try and find a cause for her seizure history. A likely pathogenic variant in the SCN8A gene was identified. The SCN8A gene is a gene that we know is tied to health and disease. It's tied to a condition called infantile epileptic encephalopathy, which is a seizure condition. The specific variant was classified by the lab as likely pathogenic, meaning that they feel as though it would impact how the gene works in the body, would contribute to developmental differences, health conditions. And they really called it that based on the information that was available at the time, that the variant hadn't been seen in unaffected individuals. It was predicted to impact the protein in a way that would make it not able to perform its typical job in the body. And the genetic change was new and unique in Ella, wasn't found in either of her parents, which is something that we sometimes see for pediatric seizure conditions. Because of those pieces, the lab had classified it as likely pathogenic. So Ella and her family had an answer for her seizure history, but they opted to participate in GenomeConnect. We then were able to share her variant information with ClinVar in that way that we just described. So providing information about the variant, her health history based on her health survey, and we were able to share that inheritance information, that it was new and unique to Ella, or what we call de novo. We then were able to see there were two other lab submissions in the ClinVar database. The first was from the lab that had done Ella's testing. So their submission likely was undertaken because of Ella's testing. but notably they didn't include the health history information or that inheritance information. Again, labs often have that information, but they don't always share it with ClinVar. So useful that we're able to do so. And then there was a second lab who had classified the variant a little bit earlier and classified it uncertain based on the information that they had available. After our submission from GenomeConnect, this second lab reached out to us to ask a little bit more about Ella's history, in particular, confirming a little bit more about her seizures. And they were interested in that inheritance information, the fact that it was new and unique to her, because in their family that they had tested, they weren't able to test parents. And sometimes that information can be really useful in clarifying an uncertain result. We were able to go back to Ella, confirm some information about her seizure history, confirm that inheritance pattern, and share that back with the second lab. The lab 2 was then able to update their classification from uncertain to likely pathogenic and reissue a report for the family that was tested at their lab. So while Ella's results and care weren't impacted by her family taking the time to share her results, her family doing so ultimately helped another family get clear genetic test results because of the additional details we were able to share. So I'd like to highlight this as just example of the power of patients engaging in data sharing and how it can really help us better understand genetics and health, help others get clear testing in the future. The other benefit of sharing genetic and health information, in addition to being used by labs, like in that example, is that this information can also be used by other groups within ClinGen who are working to better understand health and disease. So one other part of the ClinGen sort of ecosystem are expert panels. Expert panels are working to answer questions around genes and variants. And one example are our variant curation expert panels, where their whole goal is to look at specific genetic variants and try to classify them in more definitive categories. So variants that are classified as uncertain, they want to look at those variants and say, okay, what else do we know about them? Are we able to move them into a more definitive category in the likely benign space or the likely pathogenic space? These panels may benefit from patient-provided data in their variant review, and I wanted to highlight an example of that as well on this slide. So in this case, one of our variant curation expert panels was working on a gene called GAMPT, and this was a variant that had been submitted to ClinVar as a variant of uncertain significance from a number of laboratories. And so this expert panel really wanted to wade through all of the evidence and say, okay, are we able to move it to a more definitive bucket? They did so, but unfortunately it was still in that VUS space. There just wasn't enough information to move it one way or another based on what was out there in ClinVar, from labs, from the literature. But they also saw that GenomeConnect had a participant with a variant in this gene. That participant, it was classified as a VUS from their reporting lab as well, but we had really detailed health history from that participant, and we're able to go back to ask them a few more questions about their health history that ultimately was really helpful in shifting this variant to likely pathogenic. That fact that we had that tie back to them, we're able to get some detailed medical records. That was enough for this expert panel to be able to say, we do think this is tied to health and disease. Those additional details were able to help increase clarity about this genetic change. ClinGen has a number of variant curation expert panels curating across disease spaces, and I've just listed them here on the slide if that's helpful for folks to see. A number in the cardiovascular space, the cancer space, the metabolism space, ocular genetics, neurodevelopment, and as you can see on the slide, more. And they're really trying to work, as I said, to reduce uncertainty and resolve variants that are classified as VUSs or uncertain, or variants that might be classified differently at different laboratories. And detailed health information, as in that last case, can be really useful in better understanding variants. So ultimately, data sharing is important because it can help pull more information to help us answer those questions around genes, variants, and genetic conditions. Our real goal is that ultimately the more information we collect, the better we'll be able to understand how genes affect health, ultimately how to better care for patients, helping others get clear genetic test results, help better understand how we best care for folks moving forward. So that's really the goal of data sharing across sort of the genetics knowledge base. Why do we do this? The more information we collect, the better we'll be able to understand. But I do want to talk about a couple of the sort of individual level benefits back for GenomeConnect participants and their families, because I think these are important to highlight as well. So first, as I mentioned when talking through what's included in the consent, GenomeConnect enables connections with others as part of registry participation. So first, as I said, there is the option to connect with other individuals based on genetic result, but we also have the ability to recontact participants to enable connections with researchers or clinicians who might be interested in a particular gene or variant. So for instance, if a researcher contacts us and says, I'm writing a paper on gene XYZ, we can reach out to participants with variants in that gene to see if they'd be interested in being a part of that study. We never give out participants' contact information without their permission. So the ball always comes back into our participants' court. We'll let them know about opportunities should they wish to connect with others, but it is ultimately their decision to do so or not. There also is the option to receive genetic result updates as part of participation in GenomeConnect. So as I've said a couple of times this afternoon, our understanding of genetic results, our understanding of genetics, it's evolving. It might change over time. For uncertain results, we hope to put them in a more definitive category. And even others that are already in a more definitive category, sometimes our understanding shifts as we learn more. There isn't a standard approach for sharing result updates back with patients. So it's not as though every lab looks at every variant they've detected every 6 months, or every clinician calls their patient annually to tell them that there are any updates. The practices are really variable. And so we see GenomeConnect as just another way for participants to potentially receive updates about their results if we learn about anything through our data sharing. How we do this, so we facilitate result updates from our data sharing process. When we submit information to ClinVar, we take a look and see, well, how does the lab classify this, or how do others classify this? And we share result updates back with participants that choose to receive them as part of the consent process. So as I said, when folks are consenting, they can choose whether or not to receive updates from us. They also can update that preference over time. If we identify a potential genetic result update, we take a couple of steps. So we contact the reporting laboratory really to just confirm that there is an update here. And then we reach back out to the participant. That outreach really just looks like an alert. There might be an update to that person's genetic test results. And we encourage them to contact their clinician, their doctor, their genetic counselor to learn more, to request an updated report and make sure they have all the updated information. It's important to note that we don't identify all updates from our data sharing, but we do share the updates back that we come across in our data sharing with ClinVar, because we feel it could be important for folks to learn about that information. We identify updates really in two main ways. So first, we compare participants' genetic test reports to that reporting lab's classification currently in ClinVar. So if a participant uploads a report from laboratory 1, is what I will call them, and that variant is classified as a variant of uncertain significance, but when we go to submit to ClinVar, we see that lab 1 now classifies it as likely pathogenic. That's an update that we work to share back with that participant if they've chosen to receive that from us. We let them know there might be new information. The other way that we identify updates through our data sharing is by comparing to variant creation expert panel classifications. So if a participant uploads a report that says that variant is uncertain from the lab that did their testing, but we now see that expert panel has classified it more definitively in the likely benign category in this example, that also is information that we feed back with participants. So really relying on what others have submitted to ClinVar to help us identify when there might be updated information to share back. And again, we don't identify every single update, but should we identify one of these, that is information we share back with participants that choose to receive it. To date, we've shared 427 updates back with our participants, and you can see the arrows denote kind of where that classification started and where that classification is now based on our update. And they really are all sorts of updates. Some are shifting from uncertain to more definitive categories. Some might be shifting from a more definitive category to uncertain. But these are all the ones that we feed back to our participants. This process was really based on some surveys of our participants exploring their preferences, and they told us they'd want to know about any and all updates from us, and so that's what we've worked to do, really folding in any and all update that we can share back. Most are due to comparisons with the reporting laboratory. About 9 out of 10 are that sort of comparison. And then some are due to those variant curation expert panel updates as well. And so I just wanted to give an example of this in action. So a participant who underwent cancer genetic testing in 2016 due to their personal and family history of cancer had a variant of uncertain significance in the ATM gene identified. The ATM gene is tied to increased risk for breast and pancreatic and other cancers, but this specific genetic change the lab didn't know enough about to say whether it would impact cancer risk. We submitted this genetic change to ClinVar, and in doing so, compared to the other submitters, saw that the reporting lab had downgraded the variant to likely benign, meaning they didn't feel like it was tied to health, disease, increased risk. This participant had opted to receive updates from GenomeConnect, so we reached out to them via email, let them know there may be updated information about your results. If you haven't gotten a more recent report, your next steps, contact your healthcare provider or a healthcare provider in your area. We, again, give any and all updates back, including those that are upgrades from VUS to pathogenic and downgrades from VUS down to likely benign. And again, it's really based on participant preference over the years. As we've asked, folks have said, I want to know any and everything, but also because we acknowledge that downgrades can be useful in reducing uncertainty and sometimes prompt additional evaluation. We've seen participants who've maybe had expanded testing or updated testing once that VUS was shifted down to likely benign. So it can be useful in that context as well. We have done some surveys of participants after they've received updates from GenomeConnect, and we've learned that the majority, so 71%, aren't receiving updates from their clinician or testing lab prior to our outreach. And again, this gets at the fact that practices around updates are variable, and some updates might not be prioritized by labs, like downgrades from VUS to likely benign. So really highlights the ability for GenomeConnect to just be another way for participants to remain updated about their results over time. So in summary, genetic testing is evolving. Our understanding is evolving. We're getting really good at identifying variants, but questions might still remain about that specific gene, that variant, or about that genetic condition. Data sharing offers through patient registries like GenomeConnect offers a way for patients to share their genetic and health information, and that can be really helpful in increasing our understanding of genetics and health. It can help us answer questions around, is this gene tied to disease? Is this variant pathogenic? And there are some benefits back to individuals, like being able to connect with others and being able to receive updates about genetic test results over time. With that, I will put a couple of QR codes up on the slide and happy to answer questions that folks might have. Happy to answer questions that are general about genetics, about health, about GenomeConnect. If you have questions about your specific results or testing, I do encourage you to connect with your clinician. If you don't have a genetic counselor or clinician, that QR code will help you find one in your area. If you're interested in learning more about how we name variants, types of variants, inheritance patterns, I will point you to our prior GenomeConnect webinars and videos. That QR code is on the slide as well. If you want to learn more about VUSs, variant classification and reclassification, come back in September. Caitlin will talk a lot more about that as well. I also will just acknowledge I'm the one chatting with you today about GenomeConnect, but there are a number of folks who make this possible, including Caitlin and Gabrielle who've joined me. So with that, can I answer any questions? Let me pull up the Q&A.
We have one question from a participant living in Switzerland wanting to know if they can participate in GenomeConnect. And you can. We are, as Jules went over, GenomeConnect is open to anyone who has had genetic testing and who can complete the consent form in English. Our one limitation at this time is participants who are living in the European Union or European Economic Area due to GDPR regulations. But I did a quick check, and Switzerland does not fall into that category. So just wanted to provide that information.
Thanks so much, Caitlin. Thanks for clarifying that and clarifying that one restriction that we do have currently for the EU and EEA. Appreciate that. It looks like we have another question about impacts on health research and just funding and kind of the current state. I'm happy to say that ClinGen has funding in its current grant for over another year. So we don't anticipate any shifts to GenomeConnect in the near term. And we are continuing to explore ongoing funding to support this work. I can speak for myself, I can speak for our principal investigators on the ClinGen team that we're really motivated to continue to ensure that GenomeConnect is available. And we don't see any immediate concerns or concerns in the short-ish term in the next several years. Of course, if things change, we would communicate back with our participants, but no concerns in the current area. So we appreciate the question, but are happy to say our work will continue for the foreseeable future. We have another question about finding a clinician in your area based on your results. The QR code will take you to the National Society of Genetic Counselor website, and that can be used to find a genetic counselor near you based on zip code. You also can see if there are telehealth genetic counselors. So that's a good resource to find GCs near you. As you search, it will include specialty. So if you're interested in a cancer genetic counselor, can be helpful in seeing who might be able to see you. Also, talking to your primary care provider can be another step forward to identify a genetic counselor, geneticist in your area. They might be aware of folks that they can refer on to. And if you continue to have trouble, if those things don't help identify someone, feel free to reach out to the GenomeConnect team. I'll toggle over to this slide, info@genomeconnect.org. If really can't find anything, we can help be a resource as well. We also have a question about if the NIH is federally funded. And yes, the National Institutes of Health, which funds ClinGen overall, is a federal entity. And that is the bulk of where our funding comes at this time. But again, no immediate concerns for any changes. We have another question about identical twins and if identical twins are likely to have the same genetic change. Caitlin, I will call on you to help me here in case I get anything wrong, since you deal with more twin testing than I do. So for the most part, identical twins are genetically identical. So they are from the same egg and sperm that met and split, and so have the same genetic code, same DNA, and so very, very likely they will have the same variant. You're hearing me couch a little bit of very, very likely, because sometimes a genetic change might happen early in development, and sometimes that can cause one identical twin's DNA to be slightly different than the other one. So for the most part, yes, they are likely to have the same genetic variant, but there are exceptions in the genetic space, and there can be some exceptions that can lead to some slight differences in DNA code between those identical twins. Caitlin, if there's anything you'd like to layer on, please do.
No, the last thing is we're talking, this is a little bit more typical, but about like germline variants, which are variants in your genetic code in which you were born with or came from early embryonic development, as Jules was saying. There are what we call somatic changes that happen over the course of our life, and those are going to be different between each person. And so those are more acquired changes.
Thanks for that. And then one last question around sequencing.com, direct-to-consumer testing, 23andMe testing. It's a great question about sort of what types of testing we accept. At GenomeConnect currently, we're able to accept genetic testing that's been interpreted by a clinical testing laboratory. And so results that don't have that interpretation, maybe raw data, which you sometimes can get from 23andMe, other direct-to-consumers, we aren't able to share in the same way as we outlined during our discussion today. But if you have a report that has a classification from a laboratory, that's really the information that we're able to collect and share in the way that we discussed. If you have other questions about specific testing, feel free to reach out to us and we can chat a little bit more from there. All right, so with that, I will just say thank you for joining us today. Really appreciate having you all and great questions from the group. Please do join us again in September. I'm really excited for Caitlin's presentation. I think it'll be a nice deeper dive into variants and classification, and check out our prior webinars, other resources online. With that, have a lovely rest of your Thursday, and thanks again.